All right, so the reason why there's an offset between an analog ground and a digital ground is, well, let's take a step back. On the Raptor, the digital ground and the chassis grounds are tied together. The analog ground is a separate input on the Raptor, but it has an inductive filter for any noise. But this will lead to a DC offset voltage, which is what we've been measuring. And, well, for any analog input then, especially for a current-driven source, we'll need to subtract that DC offset. Yep. Okay.
Or in most of the cases, it's negligible.
Okay, it doesn't seem like it's negligible. It's like 50 millivolts or something.
15?
50. It's a lot.
Well, that's a lot.
Yep. All right. So 420 milliamp input. This is the resistor you read the voltage from. That resistor, is that the line resistance?
Yeah.
Line resistance, and then line resistance and, well, inductance, capacitance downstream if it's a long wire run. We use a voltage follower here to force a high impedance input, such that at the input of the ADC, the capacitors, well, the energy isn't sacrificed to the capacitor. You're not altering the reading by the capacitors absorbing, well, the signal. At the output of an ideal op amp, it's so input of an ideal op amp is high impedance. At the output, it's very low impedance, but you can add like a 1K resistor to the output to limit the currents of that amplifier. And then both at the positive and negative of the op amp, you add what, filter capacitor, so any noise, common mode noise,
so you'd have the RC
goes
here,
away.
Right? I forgot to draw the R here.
Okay, RC. So also an RC circuit at the output.
That's your filter. You can put the filter here.
So but RC filter after the after the voltage filter.
Here,
okay.
You could also put a filter here, really close to. This would be really close to the ADC. Right. So this RC would be really, really close to the ADC because you want to filter out any trace noise as well.
Right.
And you want capacitor there.
So these are like millifarad capacitors? Micro. Okay.
Millifarad is huge.
Oh, excuse me. I was thinking the other way. Micro. Pico even? Oh.
No, this is pico.
What's pico?
Because this is high frequency.
Pico, high frequency. Okay. So high frequency capacitors at the output, but at the input of the ADC, you can have micro.
Yep.
Okay. And then you mentioned there's like the second stage here. What is the second stage filter for?
That's if you want to make it differential and if you want to have it, if you want to have the signal amplified or not.
Oh, so if you want, you can change a single-ended signal to be differential.
Yeah.
Okay, but what's the point? Are you gonna resend this out?
Depends on what you want to do with it.
Okay.